This conference will now be recorded.
So good morning team. In today's session we will talk about what is lazy evaluation. Okay, we will prove it through the RDD programs, lazy evaluation, and then we will be talking about word count program, word count program. So based on the time, I'll talk about repartition versus collapse. So based on time table, so if time is not permitted, we will pick this as a tomorrow session. But within today's session, we will close these two comfortably. So based on the time, I'll take this. Okay. If you come here, I already created a cluster and notebook is also ready with us. Okay. So as you know, what is Spark team? Spark is nothing but a Spark session. Spark variable is holding the Spark session, as you know. Now, one more thing, as you know, we can have a multiple Spark sessions. Okay, this is one Spark session. We can create our own Spark session if you want. Okay, we can create our own Spark session if you want. So this is one way to create a Spark session. The other way to create a Spark session is from the existing Spark session, you can say a new session. Okay, it is a test session, something like this. You can also able to create a test session. Test session. Okay, both are different, but both are a Spark sessions only. Both are a Spark sessions only. Now, what is SC team? SC is nothing but a Spark context. Okay, from the Spark session also we can able to take the Spark context. But how many Spark contexts we can have for each Spark cluster or each Spark application type? For each Spark application we can have only one Spark context, whereas for in terms of Spark sessions we can have as many as you want. Okay, by default Spark is available as a Spark session. Spark context is as available as a SC. Now what happened? Not only this, now I have created my own Spark session and assigned to the Cloud Pandit session variable, and I have taken the existing Spark context and assigned to a variable called Cloud Pandit context. So meaning you can use a Spark or Cloud Pandit session to create RDD. You can use SC or Cloud Pandit context to create a RDD. So you can see, so we will use Spark contexts to create RDD. We will use Spark session to create a data frame. Clear all of you? Okay. So same here Cloud Pandit context is nothing but a Spark context. So we can able to use to create RDD. Cloud Pandit session is nothing but a Spark session we can use to create a data frame. Now this is a first way to create a RDD as we have seen yesterday. This is a list of values I'm passing to the parallelize function. Maybe here you can use Cloud Pandit context or SC to create a RDD, and you can collect the data from the RDD. These are the actions we discussed yesterday, and the type of RDD also you can see it is a RDD. Now we need to create a mount point team. So let me just quickly go to the portal.azure.com. Go to storage accounts, click on create one blob storage team. Cloud Pandit -dev-rg, click OK. Storage account name is Cloud Pandit Dev Blob. Click review plus create. Click creating. So first let's check the existing mount points. So MNT slash Cloud Pandit is also available, which is pointing to the Cloud Pandit dev block. But that storage account I deleted and I am recreating the storage account. Okay, here. So that's why I'm removing the existing mount point MNT slash Cloud. Okay, so now I want to recreate a mount point for this blob storage. So if you look at this blob storage name, this blob storage name is Cloud Pandit Dev Blob. So I'm just keeping the same name, Cloud Pandit Dev Blob, Cloud Pandit Dev Blob. I need to create a one container in the storage account called Cloud Pandit. Let's go and create a container. Okay, go to resource, go to containers, click on container, Cloud Pandit you can give, click create. Once you create the mount point, container, go to access keys, take the key of the storage account, put that storage account key here. You know, right, how to keep this through the key vault. You should read, but we already learned all those things. I hope you are already aware of that. So that's why we are directly hard coding this particular key here. Okay, so now what I'm doing, Tim, from the string I am creating RDD and displaying the RDD results. Now here what I'm doing, yesterday also we have discussed, temporary results I'm writing into the local directory. From the local directory, this is the header, this is the data. With this I'm creating a Spark data frame. Then I am converting that into pandas. Through pandas is nothing but a plain Python, team. Okay, pandas is one of the library in Python. Now that result I am writing to the temp directory. From temp directory, I am moving the file into the blob storage. Let's run this. If you go to containers, if you go to cloud container, so file should be available. It is not yet ready. Yeah, so you can see cpdemo5.csv file came now. If you see here, this is the data that we have in this file. This is the data that we have in this file. Okay, fine. This also we learned yesterday. Now let's look at the lazy evaluation example. Before I move on to the lazy evaluation example, what is lazy evaluation? I am asking you. What is lazy evaluation? What is the definition of lazy evaluation? I am asking you, Tim. Please tell me. Tell me, Tim. You don't know what is lazy evaluation.
The evaluation is performed after a real transformation is mentioned.
Can you repeat, please?
The evaluation, like reading file or any other, is usually performed after a correct transformation step,
Okay.
like count, group by.
So what are these count, collect, show, all these called? These are called, okay, so let me tell you again. Please don't forget, okay? Spark operations are two. One is transformation, second one is action. Within the transformations, we have it two types again, narrow and the wide transformation. Okay. Spark operations are two, transformations and action. Again, transformations are divided into two, narrow and wide. Narrow means no shuffling, wide means there will be shuffling. So wherever you have a shuffling, performance will be not up to the mark. Now actions are nothing but example for the actions are count, collect, show, pick, top, etc. Narrow transformation examples are select, filter, map. All these are the examples. Y transformation examples are join, group by, repartition, etc. are the examples for okay examples for the transformation. Now, what is lazy evaluation? Lazy evaluation means until we apply until we apply action, transformation will not execute. Transformations will not execute. So this is called okay until we apply action, transformations will not execute. So this is called a lazy evaluation. Okay, fine. With that, so here I am reading, right? This is a transformation or action. This is a transformation or action, I am asking you.
Transformation.
Very good. It is a transformations. Now tell me what this transformation is doing.
It's putting in the file in the path, particular path.
It is
Putting the file in the particular path.
putting the file. Hey, I am hearing very weird answers today. Yesterday only discussed a different ways to create RDD. We are creating RDD by reading the file here. What happened to you people? I don't know. Lazy evaluation we discussed, you are not answering. And basics you are not answering. Where is the problem, Tim? I am really surprised to see these answers. What happened suddenly? Why you people are like this answering? Okay, fine. But you have to go through the recording stream. Okay, if you're not going through recordings, and there is no use, because now onwards everything is coding, as you know, and I am also trying to give you my best. I'm explaining wherever you forget the things. But if you are not practicing anything, very basics, right? If you are not aware very basics also, then it is difficult. Okay? Because you are at the very basics things now. When we go to the advanced things, you will not be able to understand anything. That is up to you. Okay. So this is a transformation where we are creating RDD by reading a file. Now this is the path from which we are reading the file, and from which we are reading the file and creating RDD. Now my question to all of you is, what whether this file is available or not? Tell me first thing. Do you know whether this file is available or not in the Cloud Pandit container? Let's come here. Check cpdemo.csv. Do we have any such file here?
Yes.
No. Yes, sir.
Oh, no. No, no.
cpdemo.csv. It is not demo 5. It is a demo 5. I am looking for demo.csv. So cpdemo.csv file is not available. So now I am trying to read a file which is not available, and I'm asking type of RDD4. Do you think will I get a error here, or I will not get any error? Do you think I'll get error here, or I will not get any error? Tell
We
me
should
wrong
get
or
error.
okay. Others, oh, today you people, something happened to you people. You only told just now until you apply count or collect it will not read. Again you people are saying it will throw error. Okay. Cloud Pandit contextual text file we are creating already from this file. It is a transformation. Transformations will not get executed until you apply action. So that's why you will not get any error here. Okay, now I am using this RDD4, okay, and I am trying to split some text. Okay, whether the text is there or not, that doesn't matter, but the text I am trying to split it. So do you think will this throw any error? Do you think this will throw any error? No, this also will not throw any error, because again it is a transformations filter. First tell me what it is doing. If row is having 2, then only that will be comes out, uh, coming into the output. If the row is not having number 2 as a string value, okay, if it is not available, then we won't get any result into the filtered RDD. Okay, so now if you execute this, here also we won't get any error. Now on this filtered RDD, now I am asking count, what is the resultant count. Now what error I will get, you know, now there are 3 steps. It just build a transformation order. First reading, next map transformation, filter transformation. Now I am applying action. When I apply action, transformations will start executing. The first transformation it executes is reading file. But at the time of reading file, it realized that file is not available. Now we will get a error saying that file not found. What is the error it is saying, team? What is the error it is saying, team? Okay,
Input
everybody
File
understand.
doesn't.
Input path does not exist.
What is this feature is called in Spark? What is
Lazy
this feature
evaluation.
in lazy evaluation? What is meant by lazy evaluation?
If any
only if there
action
is an
is not
action
come,
performed,
Hmm. If any action is performed,
only then it will be executed. Otherwise, it will not be executed. Still, then it will be waiting for it.
what is going to execute? When you apply action, what is going to execute?
Transformation actions.
Okay. So you need to be very clearly explained to him. Multiple times I am explaining this. When you apply action, then only transformations will get executed. It is called a lazy evaluation. Okay. So that is what we have proven here. When you apply action, then only these transformations are getting executed. Until then, these transformations are just executed like this, but really the computation is not happening. Computation means the real transformation is not applied on the actual data. Okay. Now, what will happen if I apply action here itself? If I execute this, will I get any error here? Will I get any error here? I am asking you.
Yes,
What error I'll get?
that input file is not present will get.
Very good. So input file is not available. We will get the error here itself, because you are applying action here itself. Immediately, whatever transformations are there till here, all those things will get executed. Only transformation we have is to read a file and create RD. So at the time of reading file, it realizes that file not available. You will get error saying input path does not exist. Clear, all of you? Let's say I'll be giving cp demo 5.csv. Now, will I get any error? No, you will
no.
not get any error. Okay. Now you will not get any error. Now you can also apply map transformation. You can filter RDD. Now you can also get the count of records. You'll get the count of records. 4 records we have with the number 2. You can also collect the data to see actual data which is there in the output. See here, 2 is there, that's why it came out. 2 is there, that's why it came out. 2 is there, that's why it is came out. 2 is there, that's why it came out. Wherever you have a 2 in the data, so that particular records came in this. This is the file I read, right? You can see this file, what data this file contains. this information. I said wherever you have a year is second year, so only that result I want, I took that. Okay, everybody's clear on the lazy evaluation. Very important. Everybody's clear on the lazy evaluation or not? Are we all good?
Yeah,
Yes,
yes,
sir.
yes.
Okay, let's move on to the next concept. Tim, come here. Which one we are- Okay, I think we need to clear the cell outputs as a first step. 1 second, Tim. Let me clear all cell outputs as a step 1. Okay. I cleared all cell outputs. Just we have seen the lazy evaluation feature here. We are reading a unavailable file. We have seen map filter, nothing is failed. So when we apply action, it is directly saying file not found. Okay. Hence we proved the lazy evaluation. So same thing here, instead of modifying this particular file down, I have just corrected cpdemo5.csv and I splitting 2 in X and collected that particular RTD. You got it, Tim? Same code I kept here, but I just corrected the file name. Okay, let me re-execute all the steps if you have any confusion. See here, file is not there, but we are not getting any error when we apply created already applied map, applied filter transformation, but when I apply action, it is throwing error saying that file not found error, input path does not exist. So, but when it comes to here, so I corrected the file name. Now file name is available. So whether you are applying action or not applying action doesn't matter. Already will get created here. Map transformation will be there. Okay, filter transformation is there. Now when I apply action, so real data computation will happen, meaning reading the file, applying map transformation, applying filter transformation on the data and giving you results. Okay, that is what it has given. Okay, but even if this file is not available, we won't get any error until we execute this particular statement, because this is the place where we have applied the action. But you can also apply action at every step to see what is the output of each transformation. See, this is the output of this transformation, RDD5. So now this is a one row, this is a second row, this is a third row. Now you know map transformation we discussed yesterday. Each row we are assigning to the X, that X is splitting the entire row by comma. So when it is splitted by comma, so what happens? You can see here name, branch, year, CGPA. Instead of that, you will split the data and create a one more list, sub list. From this list, I am checking whether 2 is there in this sub list. So here, wherever you have a 2 in the sub list, only that particular result will come out. See, so these all people are from the second year students. So I got all the second year students, and you can collect that particular data. Anyhow, you collect the data here itself, you can see. Got it, team? So this is what the lazy evaluation, team. So now let's move on to let's understand a few more transformations to understand the word count program. So first you should understand word count program means, let's say you have a file with a lot of data, and you need to tell us how many times each word is repeated. For example, Spark is lazy evaluation, Spark is in-memory processing, Spark is faster than MapReduce. So if you look at your 3 statements, in these 3 statements, Spark is repeated 3 times. I'm saying Spark is lazy evaluation, Spark is in-memory computation, in-memory computation, Spark is Spark process data in memory. Now tell me, how many times spark word is repeated? Spark word is repeated 3 times, correct? Is there 2 times. In is there 2 times. Lage is there 1 time. Correct? So like that, each word, how many times each word is repeated, and it should be a case sensitive team. If we have a spark S capital here, then a small spark is 2 times it is there, and the S is capital with this spark 1 time is there. Like this, each and everything in detail, word count, each word we need to count it in the entire given text. That is nothing but a word count program. From the given text, you need to find each word how many times it is repeating. Clear team, it is called a word count program. So in order to learn the word count program, so you need to learn some basic transformation, whatever we have done yesterday, but along with that, there are some new transformations we will learn, and we will proceed with it. Now you know what is this team 1 comma 2 comma 3. What is this data type? Tell me. Only I am asking the selected part. What is the data type of this?
String.
Very good. It is a string team. Don't say that it is a list. Okay, it is a string. Very good. So 1 comma 2 comma 3 is a string. Again 4 5 6 is a string. 7 8 9 is a string. So now I am passing a string of values to the parallelize function and creating RDD. So instead of using cloud Pandit context, as you know, you can also use a SC. If you want to use that, you can use it. Now sc.parallelize, you are created a list RDD, and type of list RDD, list RDD.color. I am asking two things. What is the type of this object, and give me the result. So the type is RDD, and this is the result. This is the RDD results. Now what I am doing, list RDD dot map, list RDD dot map, lambda x colon x dot split of comma. So you know what happens now. So from the above example, if you understood, can you give me what will be the output for this team? Above transformation, whatever we have executed above, if you understood, can you give me the exam? What will be the output for this? Can you tell me?
Yeah. 1, 2, 3 together it will be in one list.
Very,
4, 5, 6 and separate. Yeah.
very good. Thank you. So that's correct, right? So we will be giving a 1, 2, 3 as we will be assigning to the x, correct? We will be assigning to the x. Now what happens? X dot split by comma. So when you split by comma, what is going to happen? 1 comma 2 comma 3, like this, there is a list. Now here just I have taken a one string and I am splitting and showing, but what we are doing is from RDD, each of the string value we are assigning to this x, that x is splitting by comma, and it is generate this kind of a list, and it returns to the RDD. Now if you collect the complete RDD result, you can see here. So first 1 2 3 splitted, created a one list. 4 5 6 it is splitted, created a list. 7 8 9 created a one list. But now what I want is, I don't want to create a, maybe I want to split it, but instead of keeping these values in a 3 different list, I want to keep all these values into a single list like this. Okay, in order to combine everything into a single list, there is the other transformation, only small change that you need to do, Tim. Maybe down I might have used that, but let me show you here. I'll explain again in the down shell also. Here, instead of map, if you say flat map and execute this and see how the result is coming here. What happened here? The flat map, what it does, it will flatten all the sublist into a single list. It will flatten it. Flat map means after map result, it is also going to do the flatting, meaning bringing all the values into a single list. Okay, anyhow, this flat map is there again in the below. We will discuss that. Okay, don't worry at this moment. Now what is happening here? Now you have 1 2 3 4 5 6 7 8 9 in a 3 different list. Now I want to combine these 3 lists into a single list. For that, if you're not using a flat map, whatever I have used, you need to do this way. The other way to reduce them and flattening them is this way. How you can flatten them is very carefully see. Map RDD dot reduce, very important. Even some of the interviewers, they will give you this as an input. They will ask you to flatten and give me the result like this. They may ask in between questions also like this. Some of the interviewers will give you sublist like this and they will ask you to flatten like this. This is very important. Okay, so that's why I'm telling you two ways. One is you can use a flat map. The second way is you can use a reduce. What this reduce does, if you look at here from map RDD, reduce is taking a two inputs x comma y, meaning first x is going to be 1 comma 2 comma 3. X is nothing but a 1 comma 2 comma 3. Y is nothing but a 4 comma 5 comma 6. Y is nothing but a 4 comma 5 comma 6. Okay, x is nothing but a 1 comma 2 comma 3. Y is nothing but a 4 comma 5 comma 6. Now when you say x plus y, you know what is going to happen when you say x plus y. See in the output it is x plus y. So if you do a x plus y, you can see here x plus y, when you do it is going to be a single list. Got it? So when you do a x plus y, when I executed, what result I got? This is what I got. Now what happens? Now first two values you have given, it just combined, this is the result. Again this is a repeated process. Again x comma y inputs we need to give, because lambda is expecting again. First we have given xy values are this, it just completed the computation. First iteration is completed. Next iteration again it is asking x and y. X will be this result, x will be a this result. Okay, x will be a this result, y will be the next value in the input. Next value in the input is 7 comma 8 comma 9. Okay, 7 comma 8 comma 9 is the next input. Now again what it has to do, x plus y. When it do the x plus y, you know right what is going to happen when it do the x plus y. Again it is going to just combine this 7 8 9 also into this. Okay, now again x and y, and x will be the this and y will be the next value. So do you have any next value here? Do you have any other value? No. So as y is not having anything, x will return the output, and when you apply this, reduce map will give you this as the output. 1 second, everything, some issue. Okay, now you can see. Because earlier I have applied a flat map, right? That's why there is a problem. Now I just, you can able to see it. Okay, now you can also see map RDD. What is the okay, 1 2 3 items. First these two items combined, that result I have taken and combined with this. Okay, see first these two, 1 and 2, I combined it, and that combined result plus the next item I have taken 7 8 9, I combined overall. So that is what the result, because there is no other value. So you need to use the reduce and you need to combine like this. But instead of applying map transformation to split it and then reduce transformation to flatten it, what transformation we can able to use to do everything in a single transformation? Flat map. Are you getting, team? Are you confusing? See, I am telling you again, you are reading the this string of values created already. That RDD data using map I am splitting and creating a sublist. That sublist I want to just flatten it. One way to flatten it is you can use a reduce to flatten it. But here if you see, to split the data, see this is your original data, this is your original. Let me just remove this unwanted things, and let me keep this result also in the this 1 second, this result also in the hidden hide code. Okay, now it will not be any confusion. So this is the string of values you have passed to create RDD. You splitted the RDD, and then you are combining. So after splitting, you splitted them using map, then you are flattening them using reduce. But instead of splitting using map and flattening using reduce, applying two transformation, we can achieve these two transformation using a single transformation called flat map. What flat map does? It do two transformation. One is it do the splitting, it also do the flattening. Okay, now you see same data I'm creating RDD again. This particular list RDD only I'm passing here, and I am splitting the data and applied a flat map instead of normal map. So now what it did, it just splitted and flattened the data, both happened at once. This is what we can able to do it using the flat map. So everybody understood flat map, because it is very important. This is what we will be using to do the our word count program. Okay, now I am going to give you some more examples. If you see 1 2 3, okay, 2 3 4 5 6 7 8 9. Now again I am splitting and flattening, both are happening at once. You can see everything happened at once or not. Everything happened, team?
Yes.
Yes. Now again come here. This is a SC or Spark Cloud Pandit context. Anything you can able to use. Dot text file. Text file means we are reading this file, okay, and we are collecting RDD6 dot collect. This is what the data. Now what I'm doing, I am splitting this data by comma. Okay, now I want to flatten this. To flatten all of this, you can use a reduce. This is a one way. One is map and reduce you can able to use. Instead of using map and reduce, what else we can do, Tim, to flatten all these values? We can simply create a RDD. We can apply flat map, so that these will be splitted and everything will be given, bring it into a single list. It is a RDD output only, but I'm just telling you as a single list, because to show you as a single list. Okay, clear? All of you clear, Tim? This is under a single list. Now what I'm doing, if at all any cpdemo.txt is there, I am removing it. If at all any cpdemo.txt is there, but it is saying false, it is not there, it is saying. Now I am trying to do this. What is this, Tim? What I'm doing here, you know already. Tell me what I'm doing here. What I
Adding
am doing.
adding this content into that file.
Very good. So you are creating a cpdemo.txt file and you are writing this content to this file. Okay, this we already discussed. Now we should be able to see this file here in the blob storage. You refresh it, you can see cpdemo. It came exactly at 7 o'clock 55 seconds. If you open the cpdemo.txt file, click edit, you can see this is what the thing is there. Spark is in memory computation. Spark will execute in distributed computation fashion. Spark is high speed. Spark is important for big data processing, something like that. I have written all these things. Okay, now I want to read this particular cpdemo file and I want to create a RDD. Now if you see, this is a one word, this is a this is a one line, this is a second row, this is the third row, this is the fourth row. There are total 4 rows. Now what I want to do, I want to split this particular words by space. Okay, If you split them by using a map transformation, what happens? See, it will be splitted by space, but for each row, one list it will create. Instead of creating these many lists, if I want to flatten them and keep it in a single list, what I should do, Tim? What I should
Flat
do?
map.
Flat map.
Flat map. Very good. So I just have to use a flat map and execute this. So it is going to come into the single list. Now tell me what will be the output for this team. So whoever understood till now, you should tell me what will be the output. Give me few answers. Like complete output I don't want. Give me like how it will appear as output. What will be the x value first time? Spark. Very good. So spark will be assigned to the x. So what I am returning? I am taking a spark and what I am returning? This is the output, right? What I am returning? Spark comma 1. Next I am taking is, I am returning is comma 1. If you see here, spark comma 1, is comma 1, in comma 1, memory comma 1, computation comma 1. So for each word I have given a 1111 numbers I have given. Okay, clear? So same numbers I have given, all the numbers I have given for each word. Now I want to say, this is what the output we have, right? Now what I want to do, I want to say reduce by key. What is meant by reduce by key is, this is a key, this is a value, this is a key, this is the value, this is the key, this is the value, this is the key, this is the value. Now I am asking reduce by key means if the key is same, if key is same, you reduce it, meaning for example spark. This spark is matching anywhere else, team? This word spark is matching anywhere else here? See, don't look at this, because our this one is only this. Okay, tell me this spark is matching anywhere. Is there any other matching sparks? Yes or no?
No.
Hmm? Very good. No.
No.
Reason is it is a uppercase. Okay, this is a uppercase. That's why there is no other word which is matching with the spark comma 1. So that's why what happens when you reduce by key, only this will come in the output, because there is nothing else to reduce. Let's say I'm going to the is there again? Yes. So now what happens? Is comma 1 is there, is comma 1 is there, is comma 1 is there. 3 times is comma 1 is there. Now reduce by key, what I wanted to do, lambda x comma y colon x plus y. So reduce is something is different and reduce by key is different. By key means if the key is same, combine the values. That is what. First x value will be is comma 1, y will be is comma 1. Now x plus y, when we do x plus y, okay, when we do x plus y, what is going to happen, team? It will be like a is key is same, values will be added. So what will be the output? Is comma 2. Now x will be is comma 2, y will be is comma 1, because one more is comma 1 is left, right? Now again, what will be the output? X plus y means is comma 2 plus 1. It is nothing but 3. So is there anything else for is? No. So that's why this is comma 3 will come into the output. Like that, if the key is same, this reduced by key is going to combine all the matched keys. It will just combine and it will sum the values to give you the total number of times this word is repeated. Got it? Come here. Is the map RDD, right? Now that is what I just mentioned here also. Okay, is come to come on. See here, map RDD. I am taking this result map RDD. dot reduce by key lambda x comma y colon x plus y. By key means if the key is same, values are going to be combined. If the key is same, values are going to be added. And if you look at the result, so this is how the result is going to be. Speed is there 2 times, spark is there 2 times, in is 2 times, ease is 3 times, computation is 2 times, like this. This is nothing but a word count program tip. So total how many steps team? So first if you see, first we are reading the data, we applied a flat map, okay, then we added a 1 to each word, then we combined the counts by key, the key is same, values we have summed it. Now if I keep everything in a single command reading file, RDD6 I am using to flatten the data. After flattening, I am adding a 1 to the each word. Then I am reducing by key. Okay. Now you can collect the results. Same data, same output. Now if you see so many variables you have used, so you should not use these many variables because this is a learning training. That's why I'm explaining you step by step. But when you are writing the code in real time, you should not use like this. This is not a good practice, because unnecessarily you have consumed a lot of variables. To avoid that, in real time we do like this in the real time coding, in the project coding. So you will read the data, on that transformation directly you will apply a flat map, on that result you directly apply a map, on that result directly you apply a reduce by key. So whoever knows the things, they will write the code like this. See, everything happened in a single line. Note, like I just used a single RDD object. Okay, everybody understood him? Till here, everybody understood.
Sir, actually, my question is, we can
Till
we can perform the same thing using Python, right?
yes.
Yeah, but still, um, we are going with PySpark here, right?
Yes.
Is it in projects that they mention that we should use PySpark for faster computation like that, or it will be our approach?
No, they will ask you to say like a PySpark. Like interviewer ask you to write a PySpark code. But you should understand the difference between Python and PySpark. What is the difference between Python and PySpark? Tell me. We discussed already.
Python is serial, PySpark is parallel computing.
Okay. So Python is a single node processing. Everything will be happening in a single computer. For example, if I write some pandas code here, okay, pandas is nothing but a import pandas as pd, and if I say what is this thing, what is this, tell me.
Dictionary.
Okay. So this is a dictionary. From this dictionary I can able to create a data. uh,
Create data.
I think the data frame only should be there. Create data frame, no, one second, let me see. So this is a p1. Okay, pandas data frame, print p1. One second. ed dot data frame. Data frame, why it is not coming? This is correct only. Df. Set type is unordered. Maybe this is also should be. 1 second team, I think they should be. Okay, 1 second. Let me just take it from your server. I have used it like that only, right? Initially. Why it is not working? Maybe key should not be a string or something. I think it should not be in a string.
The flower bracket for 1, 2, 3, if we make it square bracket, I think it will work.
Oh, correct, because it is correct. That's right. So it's my bad. Maybe I need to use something like this thing. Maybe if you want to use like this, you can also use like this. Okay. Okay. So if you want to use the dictionary also you can use it. So I was wrong. Okay, fine. So this is how you have created a data frame. Okay. So remember one thing, you can also create a same data frame in the Spark. You can create a data frame even in the Pandas. So what is the main difference is, even though this particular data frame, Pandas data frame, you are running on a cluster, and this is a Spark cluster where you have a multiple computers. But this entire execution is going to happen it in the single node, that is a driver node. Within the driver node itself, the execution also will happen. It will not use any distributed computing framework, like it will not divide the task across all the computers, meaning if you have a 10 people, I have 100 chocolates. So what you are doing is you are giving all the 100 chocolates to a one person, all the other 9 people you are keeping in idle. So but you are making the payment for them, meaning here 10 computers you have purchased through the cluster. But if you are running a pandas code, it uses only one computer, 9 other computers are idle, but you are making a payment to the cloud providers for the remaining 9 computers. So that's why what we should use is, we should not use pandas when you are using a Spark cluster. But there are some rare cases where we can't able to do some things in the Spark. We will do such kind of a logics in the pandas, then we will convert back pandas to the Spark data frame. We can convert Spark data frame, we can convert into the pandas data frame. Okay, so those all possible, we can able to do those things. But the only problem with pandas is it uses a single node and it takes more time. It will not use the parallelism, the implicit parallelism feature, whatever is there for Spark, which is not there in the Python. Okay, all of you clear, team? Any other questions? Tell me now. Anybody have any other questions, team?
Yeah, sir, now we are using pandas, okay. But now the structure of the data is actually very clean data only, right? But still, why did you choose RDD here, sir?
Where
Like
this is a
we are using
structured data,
RDDs.
structured data only you can able to process in the pandas also. Pandas is a single or two-dimensional data only you can able to pass it like this.
Okay, okay, sir. My thing is, you have a clean. No, my question is for PySpark. Actually, you used RDDs today, right?
Hmm.
And you mentioned RDTs is used only when we have unstructured data approach, right?
Yes.
Yeah, then why are we still using RDDs? Will these functions not like reduce map or flat map not work without RDDs?
So this is, do you think this is structured data? Do you see this is a structured data or unstructured data?
Yeah, it is unstructured.
So that's why we are reading in RDD. Okay. So to build up these things, some of the examples I have taken, maybe it is a structured data and I have explained to you, but ultimately we will be using this to handle the unstructured data. See, it is a recommendation is to handle the unstructured data, but there are some cases where some structured data also we need to be processed in RDD some cases, and you need to bring it back to the data frames. So such use cases are there. Those use cases will start from tomorrow. Okay. So,
Okay.
for example, one of the use case, let me tell you, okay, because you are very interested in knowing those things. That's why let me quickly tell you. If you go here, let me upload one file. One second. Mm, I'm taking a mismatch.txt data. So I'm just showing you one of the use case. Okay. So let's say what happened here, how the data is here. Is it a structured data or semi-structured data? It's like a structured
Semi-structured.
data. There is a problem with this data. Okay. So the problem with this data is, first row is having 2 columns, second row is having 3 columns, next row is having a 4 columns of data. So now what is going to happen when you read these kind of files in the data frame? If you try to read that file in the data frame, read dot, you can use, even though it is text file, you can read it as a CSV or load from mnt slash cloud pandit slash, what is that file name, tip mismatch.txt. So now if you simply say df, display of df, okay, so only first 2 rows it is taking. Now how I can able to handle this? So now the, to handle these kind of things, even though it is structured data, but there are some data is missing, it is not reading all the data. So what I wanted to do, I want to handle these things in the first RDD, sc.text file mnt slash cloud pandit slash, then you need to give here what, mismatch dot txt. So this is basically this. Okay, r1 dot collect you need to say. So when you say r1 dot collect, you can see here what is happening. So this is what is happening here. Okay. So now what you can able to do here, so you need to first r1 dot map, I'm doing like x colon x dot split by comma. Okay, I'm splitting by comma. So now I'll get a r2. So as I mentioned, you no need to create these many variables. This is as a training, so that's why I'm creating these many variables to show you. Now what happens, the length of this list is 2, the length of this is 3, length of this is 4, but I know the max length is 4. So now what I can do, I can develop some function. Okay, def fill missing values, fill missing. Okay, fill missing values. So whatever x I'll give, it has to check for I in, okay, a range of length of x. What is length of x, team? So for example, if I give 1 comma Rama, what is the length of X? If I give 1 comma Rama, what is the length of the list? Length of X?
1.
1. 1 comma Rama length will be 2. Okay. It is not index. I am asking length. Number of items is 2. So now max I want is up to 4. What I will do for the X? Okay. So 2 times I'll be adding a no data to the X. I'll be adding a no data and I'll be returning this result. I'll return this result. I'll return this result. Now what is happening here? So you can simply do otherwise X dot append of no data. 2 times I am appending the no data to the X, meaning now when you pass 1 comma Rama, length of X is 2, range of 2 comma 4 means how many times range will iterate? Range of 2
2
comma
times.
4, how? 2 times. So 2 times no data will be added to the X, meaning 1 comma Rama, comma no data, comma no data. 2 times will be added no data to the first row. Next, I'll pass 2 Krishna Bangalore to this X. Length of X is what, team? Length of X is 3.
3.
3 comma 4 means how many times range will iterate? Only one time. No
1.
data will be added one time to this. Now this I'll pass 4. Length of X is 4. Range of 4 comma 4 means how many times it will iterate?
0.
0. 0. So this is what I'm doing. From R to each value, I am like each uh, item I'll be passing to this fill missing, I'll get a R3. Now if you say R3 dot collect, because I'm showing you as your fill, okay, first you need to execute this fill missing thing, then you can execute this. Now you see, so all the data is uniform now. Okay, now what you can do, this R3 you can able to RDD, you can able to convert to the data frame dot show. Okay, this is one of the use case. If you want to pass the headers, you can also pass the headers here. So but anyhow we will discuss in detail here. The length also I hard coded, but I should not hard code length also because we don't know what is the max length of the row, right? So all those things we'll discuss tomorrow, because as you asked today, I just covered to clarify your doubts. Okay, phone number. So I just have given like this. If you say the data will be proper. Now what happens? You brought the data into the data frame again, but you handle these issues in RDD. RDD is more efficient to handle these kind of things, because when you read these things in the data frame, the initially data itself not coming, so you can't do anything at the time of reading itself. Data is not coming means, got it? So that's why you
Yes,
need
sir.
to handle the additive. So we will see these use cases, and repartition and coalesce also we will discuss tomorrow. It is very important concept for your real-time performance tuning. It is important for your interview. It is important to know each and everything what is happening in the background, the partition, shuffling of data, how it will happen, which one to use, when to use. Very important to know. That we will discuss tomorrow. Please let me know if you have any other questions. Any other questions, team? No questions? Okay, fine. If no questions, then thank you all. That's all for today.